So here's the function given in the problem. And the question is, what's the largest possible value for the slope? So just, you may not be able to use a graphing calculator on a test problem like this, but it's important to realize that because it's primarily a function of a cosine of x, it is a periodic function, just like any sinusoidal function. And the reason it continuously rises is because of this term here. So as x increases, so does y. So there's a ongoing vertical shift upward due to this term. All right, otherwise it's just a periodic function. And you can see, just by inspection, or if you couldn't use a graphing calculator, you could imagine in your mind that the maximum slope in this period is somewhere in here. We don't know exactly where, but somewhere in here. And then that same maximum slope is going to be found repeatedly throughout the graph at increments of one period, whatever one period is. And so the graph of the maximum slope is also periodic, and it's going to look like this. It's going to be shifted upward a little bit. But anyway, the maximum slope is right here, whatever that value is. And that is exactly what happens when you take the derivative of y. So y prime, x goes to 1. So there's still a vertical shift, but it's a constant vertical shift. And as we said, it's going to be 5/4 sine 5x over 4. And so this is the amplitude. We talked about that. This is the frequency. The period is 1 over the frequency, or 4/5 times 2 pi equals 8 pi over 5. All right, so as I tried to explain, this factor here, sine of 5/4 of x, is going to fluctuate from a minimum of -1 to 1. So again, obviously, the slope is going to reach a maximum when this is 1, which means it's going to equal 1 plus 5/4. And that would be 9/4. So that's the shortest way to the correct answer.